What is going on, guys? Welcome back. In this video today, we're going to take a look at FastEmbed, which is a Python library that allows us to easily work with embedding models locally on our system, even if it's not a very powerful system. It's optimized for speed, simplicity, and also for running on hardware that doesn't have a dedicated GPU, for example. While it isn't a perfect solution for every embedding use case, it is probably the easiest and quickest way to work with embedding models locally. We're going to take a look at how to work with text embedding models, image embedding models, and we're also going to see how FastEmbed is implicitly used by Qdrant since it's made by the same people. If you like this video, let me know by hitting a like button and subscribing. And now, let us get right into it. Alright, so we're going to take a look at FastEmbed in this video today. For this, we can start by taking a look into the docs because FastEmbed has a specific niche that it tries to serve to. So this is not a general embedding library or framework that you should be using. This is specifically for lightweight, fast, and local embedding generation. It is very simple, it's very easy to use, it's very lightweight and fast, and primarily it is like that because it uses the ONNX runtime, which is Open Neural Network Exchange, basically the PDF format or standard for neural networks. So we don't have dependencies like PyTorch, TensorFlow, or something like that. We can just use the ONNX runtime to serve the models, and they also only offer specific models which are powerful. I do miss some of the state-of-the-art models that rank very highly in the MTEB leaderboard, but essentially this package is specifically meant for local embedding models in a lightweight and fast manner. So this is perfect because I'm recording this on a laptop here. We can take a look at the fast fetch output. I just have a basic ThinkPad here. I don't have a dedicated GPU, even though you can use FastEmbed with a GPU as well, and we're going to talk about this. But as I said, the focus here is primarily on lightweight embedding models. So without talking about this too much, this is, by the way, the GitHub repository. They also have some examples here, but without talking about this too much, let us get right into it. I'm going to navigate to my tutorial directory, and here we're going to initialize a new project, which is going to contain FastEmbed. Now, if you want to do this in the simplest possible way, you can just use your local Python installation. So you can use pip or pip3 install, and then FastEmbed, and if you want to use the GPU version, you can say -GPU as well. In my case, I'm not going to do that. I'm going to create a UV project. UV is a Rust-based Python package manager. You don't need to worry about this if you don't want to use it. But in my case, I'm going to say UV init, and instead of saying pip install, I'm going to say UV add. So UV add FastEmbed. And that is basically all we're going to need for the first script. What I want to show you is how to do a very, very basic text embedding just to get started. So we're going to open up a file called main.py. In my case now it has some basic code that I'm going to delete because I don't need that. And here now we're going to just write some sentences and see if we can do a very basic similarity search kind of thing with text embeddings. So we're going to start by importing numpy as np, and also we're going to import from FastEmbed the class text embedding. Also, let me go into full screen here. And now we can do something simple, just a hello world like example. I'm going to say documents is going to be a list of sentences. So we just have some statements here, and we're going to see if we can do some basic text embedding and similarity search. And what I like to do here as an example is I try to come up with sentences that can be confusing for a very dumb model because it uses only the context of individual words, whereas better models immediately realize that the meaning is different even though the word might be quite similar. So a perfect example here would be if I do something like I don't, and maybe I should use double quotations here now, I don't like Apple because their products are very expensive. Now, obviously the word apple here is a fruit, but in this context, it is the brand of the technology company. So the second sentence, if I go with something like I don't like bananas because they taste odd, that is also a sentence, and this is focusing now actually on a fruit. And the third sentence will be something like I don't like Microsoft because their OS produces a lot of blue screens. So if you are a very simplistic embedding model, you're going to say apple, bananas. There is much more similarity here. So I'm going to say that this is closer in vector space. I'm going to embed these two things closer in vector space. But if you're somewhat intelligent, you're probably going to put Microsoft and Apple closer because you understand Apple here in this context is a technology company. So let's see what happens here. We're going to say embedding model is equal to text embedding. And by just doing this, we already have an embedding model. We don't even need to specify any repo, any identifier. We just get a default embedding model here out of the box. But I'm also going to show you how we can choose a different one later on. And now we can say embeddings is equal to np array. And then we have to call list, because what we get from the embedding model is a generator. So to actually realize it, to actually evaluate it and turn it into something, we need to typecast it into a list. This forces the generator to generate basically. And then we want to have it as a NumPy array. So embedding model.embed, and we're going to embed our documents, the 3 sentences that we wrote. Now, what I want to do here is I want to see what the differences are. So the distance in vector space. For this, I'm going to say diff is equal to embeddings, and then now we can add a new dimension. So we can say colon, none, colon, and then we can subtract from this embeddings, and then we can do none here. This basically combined with NumPy broadcasting will allow us to subtract every vector from every vector, and then we can take that and create a distance matrix. So distance matrix is equal to np linear algebra dot norm. Here we're going to put in the diff, and the axis is going to be the last one, so -1. And now we basically have for every document, for every sentence, how far apart it is from all the other ones. That is the matrix. Now we can either just print the matrix like this, or we can use a more beautiful way by iterating over it. So I'm going to copy paste this here now, because this is just really a display. So we just go over the documents, and then we show distance between I and J, which is the 2 different documents, and then we just show the respective cell of the distance matrix. And if I run this now, we can see the distances, and we can also see that the apple sentence and the banana sentence have a distance of 0.877. We have the distance between the Apple and the Microsoft statement. This is the closest one. So these are 0.78, which makes sense because both are talking about technology companies that produce computers being bad because of something. And then the largest distance is between the banana and the Microsoft sentence. So yeah, when we go back into code, you can see that the only thing that we had to do, because this is just printing stuff, we don't need to do that. We don't even need to do any distance calculations. The only thing that we had to do in order to use an embedding model, a text embedding model, and apply to documents is create an instance and then just call the embed function. This then creates a generator, which we can turn into a list by calling list, and then we can turn this into a NumPy array if needed, which in this case is needed because we want to do the broadcasting, but that is basically all we have to do. Now, of course, we can also choose a different model here for the text embedding model, but this is not just any Hugging Face repository. You cannot just go ahead and type any identifier or any repo in here. There is a certain list of models that we can use. Now, if you want to find out what that list is, let's open up a new file. Let's call it list models.py. Then we can say from FastEmbed import text embedding and image embedding, which is the next thing that we're going to talk about, embedding images. And then we can just say print, then a list comprehension x model for x in text embedding list supported models. And of course, we can do the same thing for the image embedding. This is going to give us the repos or identifiers for all the models that we can use. So I can just say uv run list models here. And you can see I get these and I get these, which are the vision models. So I think the default here, if I'm not mistaken, is the small one. So we can choose any other one to see how it performs compared to that. For example, let's go with this one here, the mixed bread AI. Let's copy this. Let's go into our main PY file. And now all I have to do is in these parentheses here, I have to put this, and I also have to put quotation marks around it. There you go. And now when I run this, we will get different values, but the logic stays the same. And as you can see, what also stays the same is the proportion. So 0 and 2 are still the closest ones, and 1 and 2 are the ones that have the greatest gap, the greatest distance. Now for the image embeddings, it's basically the same idea. I have 2 images here, image 1 and image 2 JPEG. I can also take a look at them. As you can see, it's just some dog, and the other one is also a dog. And then what we can do now is we can go into the main PY file, and instead of importing text embeddings, we can just say image embedding, and instead of having documents, we can just have paths to the images. So let's go and say image embedding here. We can of course also use the default one, but we can also specify a specific one like Qdrant ResNet 50 ONNX. And then basically we can get rid of all this and just say embedding list is equal to list embedding model dot embed. And we can just pass a list of paths to images. So image 1 JPEG and image 2 JPEG. And in this case, I'm not going to do anything with them. I'm just going to print the results so you can see what they look like. And we also don't need NumPy. So let's go UV run main py. Again, if you don't have UV, just Python or Python 3 run main py. But as you can see, this is what it takes to use an image embedding model locally. Now, implicitly, we can also use FastEmbed by using Qdrant. So we can go and say uv add or pip install and then Qdrant-client. This is going to install Qdrant. Qdrant itself relies on FastEmbed if we use the Qdrant add method. So to add stuff to the Qdrant vector store. If you don't know what Qdrant is, I recently made a video about it. It's basically a vector store optimized for filtering and custom tagging and all that. But behind the scenes, it relies on FastEmbed if you don't provide a specific model. If you don't do the embedding yourself manually with sentence transformers, for example, you basically use FastEmbed behind the scenes. And I can show you that. Here we have a code example using Qdrant. I copy pasted it because this is not a Qdrant tutorial, but basically we have a bunch of documents. We have a Qdrant client that runs in memory. And here, this line here shows you that we're using FastEmbed because we can say client.setModel, and this automatically says, when you're using FastEmbed to add stuff to the collection, to add documents to the collection, use this model here. This, of course, only accepts the models that also FastEmbed accepts. But we can run this. This is a very basic rack example. I can just say uv run main py here again, and it's going to answer the question by retrieving the 3 most relevant documents as context. Or in this case, obviously, it's only going to retrieve the context. It's not going to answer the question. Finally, the last thing I want to show you here is how we can use the GPU. Now, I cannot really demonstrate this because I'm on a laptop that doesn't have a dedicated GPU, but what you would do is you would say either pip install or uv add and then FastEmbed-GPU. This is a different package which allows you to use GPUs with FastEmbed, but it doesn't happen automatically. What you need to do is you need to craft a basic example again from FastEmbed import text embedding, for example. And then when you define a model, when you say embedding model is equal to text embedding, you don't just specify the model name, but of course you can also do that. So that would be the model name. You can also explicitly do that as a keyword argument like this, model name is equal to, but what you need is the option for the GPU. So we can say providers is equal to, and then a list. And in here, I'm going to say CUDA execution provider, which is going to allow us to use CUDA, which is of course NVIDIA's technology. So if you don't have an NVIDIA GPU, that's not going to work. But basically, we can see that I will get an error message here, but this is how you allow for GPU usage. In my case here, it crashes because it says it doesn't have CUDA installed. But yeah, that's basically it. FastEmbed is the Python library that allows you to do all of this super easily locally. It's great for prototyping. It's great for lightweight use cases. You don't always need very sophisticated models. Now, they do claim here, to be honest, that it's the state of the art. I don't believe that's the case because if you go to the MTEB leaderboard, I think the strongest model as of right now is, I'm not sure how it's pronounced, Calm or KALM, which is basically Gamma, so Google's open source model somehow made for embeddings. And it's not supported by FastEmbed. So I'm not sure if it's really state of the art, but you do have decent models that you can easily run on CPUs, on laptops, on lightweight machines in a simple and fast way. So that's it for this video today. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, in case you're interested, on my website, you will find a services tab and a tutoring tab. There you can contact me if you need help with a project, if you need a consultation, if you need someone to work with you on a freelance basis. You can contact me at the bottom of these pages via LinkedIn or email. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you for watching, see you in the next video, and bye.